Welcome to the third section in Chapter 6 on solving systems of equations. Our objective today is that I can solve a system of linear equations using the elimination method and can identify how many solutions there are. So, we have so far learned how to graph systems of linear equations. We've learned how to use the substitution methods to solve systems of linear equations. Now we're going to learn our third method, elimination. Now, elimination, what we're going to do today is fairly easy, straightforward elimination equations. When you're done with today, you're probably going to say, I think you'll say, why don't I just use elimination all the time? And that's okay. Even after the next lesson, a lot of students will pick that. But I'm going to tell you that these are a little easier than what we're going to do tomorrow, because we're not going to need to adjust the equations at all or much at all to get the elimination method to work for us, which makes them a lot easier. So we're gonna do elimination light today, and we'll do a little more difficult elimination in the next lesson. So let's jump into it. Elimination uses either addition or subtraction to eliminate one of the variables in the equations and thus solve the equation. So here's a little hint. Now I'm going to say that I don't really use this hint. What I end up doing is always making opposites, and I'll show you that in a second. So I can always use addition, because that makes sense to me. Now, if you want to do this idea of subtraction, feel free to. If that makes sense to you, that is okay. So this is basically what we're going to do. We're going to notice, or tomorrow we're going to create this situation, but today we're going to notice that we're going to have variables that are either opposite of one another or the same as one another. And we're going to try to make those zero. We're going to try to eliminate them so we only have one variable, because that's been the struggle all chapters so far, is that I've got two variables, and so we need new strategies, new methods for dealing with having two variables. So in this case, I've got 3x and I've got a negative 3x. What do I need to do to make that 0? I need to add them together. And I've got 4x. And I've got an x here. What do I need to do to make this 0? Well, I need to subtract 4 x's, and that will make this all 0. This is what we're going to end up doing tomorrow. So we're going to be adding these coefficients in a very specific way. Now, what does Mr. Gibbs do? Mr. Gibbs always turns this into plus a negative 4x, because I think it's easier to see when we actually get to the equations. But enough talking, let's just go ahead and jump into one of these and see what's happening. So immediately you should notice this right here, that this is a negative 3x and this is a positive 3x. So the elimination method tells us that we can just add these two equations together and then solve for the variable, to solve for one of the variables, and then we're just going to be doing exactly what we did yesterday, is taking that equation, plugging it back into one of our original equations, checking our work, and writing our solution as an ordered pair. So, but basically, we're just making an addition problem out of this. I'm just going to add these equations together, just like I would add two numbers together. These happen to have variables in them, but just as long as I stay true to everything in here, I'm not going to violate algebra at all. As long as I'm adding straight down, just like you add straight down when you do hundredths and tenths and one places, etc. So I've got negative 3, and I'm going to add 3x to that, and I get 0. Now, I never write that down. That just goes away, right? And then I've got a positive 4y, and I'm going to add negative 6y to that, and I get negative 2y. It's just like combining like terms, right? And this is going to equal my 12 plus 18, which is 30. And now I've got this really simple algebraic equation that I need to solve. This is what makes the elimination process a little easier at times, especially when we've got specific situations like this, is that the algebra is then a lot less tedious, and I get y equals negative 15. Now we can't stop there, right? We need to take this and we need to plug it into one of our original equations and figure out what our x is. So it does not matter which equation you pick. I usually just plug it into the first equation, and I get negative 3x plus 4 times negative 15 equals 12. And now I'm doing algebra again. This is negative 60 equals 12. I'm going to add 60 to both sides, and I get that negative 3x equals 72, dividing by negative 3, and I get that x equals a negative, oh, what is that? That's 24. Okay. Notice why we didn't use the graphing method here. Okay, I just want to pause and let you notice that we would have needed a really big piece of graphing paper and likely would have made mistakes if we're using x and y, are using our y-intercept and slope, because as we draw a straight line, you know that it's really hard to continue to make that perfect. Okay, so we've got an x and a y. I always want you to check using your second equation. In this case, I plugged into this one. If I plug back into this equation that I found my x from, I'm going to get a true statement because that's the equation I used. The question is, if I plug into this equation, am I going to get a true statement? So I've got 3 times negative 24 minus 6 times negative 15 equals 18. Now, I could do this, but I want to show you that this part of checking shouldn't take you a lot longer, because some of us fear that hard work. So you just take your calculator out real quick if you want to. That helps us also keep our focus on what we're really trying to do. And plug it in. Okay, so this is a negative 42, and I'm going to be, a negative times a negative is a positive. I'm going to be adding whatever 6 times 15 is, and I get 18. 18 equals 18. I got a true statement. That worked out, and now I'm really confident that my final answer is negative 24, negative 15. That is the moment in time where these two equations are going to intersect if I graph them on a coordinate plane. This is the only x and y that I can plug into both equations and get a true statement. Let's try the next one. Feel free to try this on your own now if you're feeling confident. I'm just going to add these two things together. So negative 2 plus 5 gives me 3x's. This goes away because this is 4y minus 4y. And then I have a 12 over here. I'm dividing by 3. X equals 4. Now I'm taking this and I'm plugging it into one of my original equations. It doesn't matter which one you pick. I've got a negative 2 times 4, because I know that that's what x is. And I'm writing the rest of my equation. The only thing I've changed is that instead of writing x, I've written a 4. I get negative 8 plus 4y equals negative 20. I am going to add 8 to both sides. That's the thing that has nothing to do with the variable I'm looking for. I've got 4y equals negative 12. Divide by 4, divide by 4. Y equals negative 3. Sorry, I'm left-handed, but the nice thing is that's all stuff you should be able to do without me. Okay, so now I've got an x and a y. What do I need to do? I need to check it. And I am going to use the second equation that I did not use yet. So I've got 5 times 4 minus 4 times negative 3 equals 32. Well, this is 20. This is a negative times a negative, so it's a positive. 20 plus 12 does equal 32. 32 equals 32. Check mark. I'm going to write my final solution. I have 4 comma negative 3. I'm going to box that so everybody can see that that is my solution. Okay, I think I'm going to switch to another color so you can make sure not to get these up here confused with what we're doing down here. Now notice that up here I had opposite signs. Now I've got the same sign. So this is what it's talking about up here. If you have the same sign, subtract. So you could set up a subtraction problem if you would like and say 4 minus 4x, 2 minus a negative 3. Ooh, be careful. 28 minus 18. If that works for you to remember these differences, go for it. What I always do in my mind though is say that they've got to be opposites, okay? And I think that helps with what we're going to do tomorrow. So instead of doing that, I'm going to just rewrite these equations real quick, but I'm going to make one of them opposite. So I'm just going to change this second one. So I'm just rewriting my first equation. This is 4x plus 2y equals 28. And this equation right here, I'm going to change all the signs. I'm going to multiply both sides by negative 1. So this becomes a negative 4x. This becomes a positive 3y. And this becomes a negative 18. This is what I mean by the fact that I always add, because this makes more sense to me. I'm just combining these equations. Okay, so 4x minus 4x, that's nothing. 2y plus 3y is 5y's. And 28 minus 18 is 10. I'm going to divide by 5. I get y equals 2. I'm ready to plug this in to one of my original equations. I'm just going to keep going with plugging it into my first equation. And I get 4x plus 2 times 2 equals 28. 4x plus 4 equals 28. Subtract 4 from both sides. I get 4x equals 24. Divide by 4. I get that x equals 6. Okay, now I've got an x, I've got a y. I'm going to check to make sure I did all this right, because this is a lot of steps. So I'm going to take this second equation, 4 times 6 minus 3 times 2 equals 18. 24 minus 6 equals 18. That sure does. 18 equals 18. Check. Okay, now I've checked it. I'm ready to write my solution. My solution is my x is 6 and my y is 2. I'm going to box it so it's really easy for Mr. Gibbs to tell that I have found my solution, and here it is. Okay, let's do this next one. Now, if you haven't already, which I hope you did, I want to see you going ahead and trying this on your own and then coming back to it and seeing that you did it right, or seeing where you made a mistake, because we really learn from our mistakes, especially early in the process. So see what you can do by yourself and then come back and see what I did. Okay, so I'm going to rewrite these because I want these signs to be opposite. So I've got 3x minus 5y equals negative 34. And this next equation, I'm going to change all my signs. I'm going to multiply everything by -1 because I want these signs to be different. So I've got a positive 5x plus 5y equals a positive 10. Change the sign, change the sign, change the sign. They were all negatives, now they're all positives. And now I'm just putting these equations together, adding them together. 3x plus 5x is 8x. This goes away, and this is -24. Divide by 8. X equals a -3. I'm going to circle that. Now I'm taking this and plugging it up into one of my original equations. And so I've got 3 times -3 minus 5y equals -34. I've got -9 minus 5y equals -34. We're just doing a little algebra to finish this off. I'm adding 9 to both sides. I get -5y equals a -25. Divide by -5. I get y equals 5. Now I've got an x and a y. I just need to check my work. And I'm going to use the second equation to do it. I've got -5 times -3 minus 5 times 5. And this should equal -10. And let's see if it does. -5 times -3 is 15 minus 25 equals -10, and that sure is true, that -10 equals -10. So finally I'm going to write my solution as an ordered pair. So I have -3, 5. I'm confident this is correct because I've checked it with both equations, and I am finished. Again, we've got a few problems on the back. We'll probably go ahead and do those as warm-ups the next day. You can let me know if you have any questions. But make sure you're really feeling confident after these 4 problems we did over here about this before our next class. Thanks.